Hey everyone, this is Mr. Beckstrom, and today we're going to take a look at a word problem. And this is a maximization problem because we're trying to get the largest area that can be enclosed. So let's go ahead and start on this. So it says a farmer has 9,000 meters of fencing and wants to enclose a rectangular plot that borders on a river. If the farmer does not fence the side along the river, what is the largest area that can be enclosed? All right, so with these types of problems, we see what are they trying to minimize or maximize. In this case, they're trying to maximize the area. So that's going to be our objective function. So I'm going to start with area is equal to, and the area of a rectangle is just going to be base times height. So that's going to be that, we'll call this the base. So that's 9,000 minus 2x times the height, which is x. All right, so if we want to simplify that, we can write a is equal to 9,000 times x is 9,000x, 1,000x, and x times negative 2x is minus 2x squared. Now you may say, well, where do we put this 9,000 in? Because isn't that the perimeter of the rectangle, not including the side that's adjacent to the river? And it has already been included for us. So at some point, somebody came up with that perimeter equation that came out to 9,000 minus 2x, and they already did the replacement for us, putting it over here. So at this point, all we really have to do is to graph it and find the maximum. Also notice that this is in terms of one variable. So we are good to go. So we want to find the x value that is going to give us the largest possible area. So going to our calculator, I'm going to go ahead and put that equation in here, which is 9,000x minus 2x squared. So 9,000x minus 2x squared. All right. Next thing we want to do is graph this. I'm going to start with a zoom normal and see that all I'm getting is a line that looks like it's going on top of the y-axis. So we definitely need to change our window. Let's go ahead and go to zoom fit. Give that one a try. So that's zoom. And we may need to mess with our window a little bit. It doesn't really help too much. So in this case, I would go to my window and I would say for values of x, it's going to end up getting pretty high. So after playing around with it for a little while, I was able to get this graph. Let me kind of explain the process of that. So the first thing I did was I said, what does x have to be between? Well, it can't be less than 0. So I'm going to make the 0 the beginning of my domain on my window. And it actually can't be greater than 4,500 meters. And the reason is because if we made this base here, the width of it, as small as possible, that two x values together would be approaching 9,000, which means each one would not be able to get over 4,500. Because once they get 4,500, that's for both of them, that's all of your fencing, and that would give you a 0 here. So I did that first in window. So I went from 0 to 4,500. And then I ended up just putting larger and larger numbers in there, exponentially large, until I got to about 12 million. And it gave me a nice graph here. So at this point, we just want to find where the maximum value is. And that's going to do second zoom. Oops, excuse me. Second trace. Go to the maximum function, We need a left bound, so go somewhere to the left of that maximum. A right bound, so go somewhere to the right of that maximum. And enter. And here it is. So, wow, that's a huge area. So 10,125,000. So this would be the largest possible area that we could find. And that would be when we let our X value, or the side of our fence there, be 2,250 meters. All right. If you have any questions, please let me know and have a great rest of your day. Thank you.